Problem 19 gives us the graph of f prime over the domain from -7 to 7. And it says if f prime has 4 zeros during this time, sorry about that, how many relative maxima does f have on this interval? So we see 1, 2, 3, 4. Those are the 4 zeros we're talking about. And we want to know about a relative max. Relative max occurs when the first derivative changes from positive to negative. Well, the first time the first derivative is equal to 0 is right here, and that's a change from negative to positive. That's a relative min on f. The second time, there's no change in sign. So that's neither a relative min nor a max. The third time, we do change from positive to negative. So that's going to be a relative max for f. And then the last time is like the first time, it's a change from negative to positive, which means it's a relative min. We're asked about a relative max. There's only one situation when that happens. So our answer is A. With number 20, we're given the graph of f prime again, and we have to state whether the following statements are true or false and give a reason for each answer. So 20a says f is decreasing for the interval from -1 to 1. Here's -1, here's 1. We see that the graph is decreasing, but this is not the graph of f. This is the graph of f prime. So this is false. Okay, f will be decreasing when the derivative of f is negative. Okay, but the derivative of f is positive from -1 to 0. Right? So the reason why this is false is because f prime is positive on the interval from -1 to 0. And that's an issue. For part B, f is increasing on the interval from -2 to 0. Here's -2, here's 0. During that time, the derivative is positive. Positive derivative means increasing function. This is true because f prime is positive. C states f is concave up on the interval from 1 to 2. Well, 1 to 2, we have a function, or rather a derivative, which is increasing. Increasing derivatives match up with concave up functions. So this statement is true, right, because f prime is increasing. Statement D says f has a local min at x equals 0. At x equals 0, the derivative changes from positive to negative. That means local max, not a local min. So this is false. All right, because f prime changes from positive to negative. We're looking for when the derivative changes from negative to positive if we're trying to find a local min. And finally, E states f has an inflection point at x equals 1. Well, if the derivative changes from increasing to decreasing, or vice versa, then this statement will be true. Here's 1. The derivative is decreasing before and increasing after. So this is true, right? Because f prime changes from increasing, or rather from decreasing to increasing. In our last problem in the homework, we're given the graph of f, and for each of the following, we have to label f prime as positive, negative, 0, or non-existent, and then determine if f prime is either increasing or decreasing or neither. So at A, which is right here, our function is decreasing, right, because this is the graph of f. Function is decreasing and concave down. So if the function is decreasing, that means that f prime is negative. Since the function is concave down, that means f prime is decreasing. At B, we have ourselves a cusp. That means that f prime does not exist. Okay. And additionally, since f prime doesn't exist, it can it can't be increasing or decreasing, so we're going to have neither. For C, the function is now concave down again, but it is increasing. Since the function is increasing, f prime must be positive. Since the function is concave down still, f prime is still decreasing. With D, we now have a spot where it looks like the function is decreasing again. So once again, just like before, f prime is going to be negative because our function is decreasing. In addition to that, we have what looks to be a point of inflection happening at D. Concave down before, concave up afterwards. So there is no concavity at that point. This is another situation where we have neither. And finally with E, we are increasing and concave up. Since the function is increasing, the derivative must be positive. Since the function is concave up, the derivative must be increasing.